This week on the Tech on Tap podcast, we bring in the Fly Guy, Mike Peppers, to talk about quality of service and the new performance goodness in ONTAP 9.3.
Welcome to the Tech on Tap podcast with Justin Parisi and Sully the Monster.
I love NetApp.
Oh, yeah.
I love NetApp because it's so funny.
Hello and welcome to the Tech on Tap podcast. My name is Justin Parisi. I am all by myself in the studio. Andrew is out of town. He's in Australia doing his thing down under. And I'm here with Mike Peppers today. And what we're going to do today is we're going to talk about QoS. We had a podcast previously on this before. We're going to talk about it a little more in depth. And then we're going to go into the overall features in ONTAP 9.3, which just released a couple weeks ago as a release candidate. So, Mike Peppers, hi.
Good morning.
How's it going?
Doing well. And you?
Doing well.
Thanksgiving?
Yeah, I did. Ate way too much, as usual. I have no control mechanism there. But I will make up for it by podcasting my butt off. But yeah, so we just got back from the Thanksgiving break, and we are ready to go. Insight is behind us, but we have lots of work to do still. So, Mike Peppers, if you could introduce yourself, let everybody know what you do here at NetApp and how to find you on social media.
Okay. So my name is Mike Peppers. I'm a technical marketing engineer at NetApp. I cover SAN, Performance, FlexArray, FLI, QoS, and FC NVMe. And you can find me on social media. I am NTAPFLIGuy.
Yeah, you do quite a bit here. Most in the SAN space here, also the performance area.
Mm-hmm.
And some of the performance stuff we have in ONTAP 9.3 is interesting. But before we get into all that, let's just go with a QoS primer, like, the quality of service in ONTAP, and let's just talk about in depth what we offer and how it works.
So there are three primary QoS offerings as of 9.3. The first of which was introduced in ONTAP 8.2, was QoS Max. A Max is the idea being that you are going to put a ceiling on a workload so that you stop it from being able to impact other workloads that are in the same shared storage space. And so you're protecting other workloads from the workload you're putting the Max on. The second type of QoS is this QoS min, or minimum, which is you're putting a floor in place where you're saying that I am going to guarantee that a specific workload is going to get some number of IOPS. And I will guarantee this by attaching a deadline to every IO that comes in, and then matching that deadline to make sure that I meet it by doing things like allowing you to jump queues. This would be sort of like a fast pass at Disney, where you essentially are going to have fewer turns that you're going to have to go through, so you'll get to the front of the line faster than someone entering the standard queue. And so that's how that guarantee works. But what you're doing, unlike with Max, is you're actually protecting the workload you're applying the QoS min to, up to the number of IOPS specified. The last and most recent, and that was introduced in ONTAP 9.2 for NAS and 9.3, or for SAN, and 9.3 for NAS workloads as well.
Okay, so with the QoS mins and that sort of thing, I mean, you mentioned you don't have you don't necessarily babysit it, but do you have alerting methods that we can use to kind of watch it for us?
Oh, absolutely. So one thing I would encourage anyone listening to this is, if you manage ONTAP, you should have on-command unified manager, which with 7.2 includes on-command performance manager. They are free tools that are available to you that will help you to manage ONTAP. What you specifically can do with those is that you can set thresholds so that when you start getting close to one of those maxes, or as you pass one of those maxes, that you are alerted to that. And that way you would be able to see that I'm going to need to adjust the the max or the min, whatever QoS setting that you have assigned to a given workload based on changes in that particular workload. Now, of course, in the case of adaptive, you require a little bit less attention in that you are already dynamically changing the amount of bandwidth that a given workload actually has based on its size. And so that's what's supposed to reduce the administrative footprint.
Okay. So with minimums, I mean, there's been a debate over whether these are guarantees or not. Can you kind of cover if they are guarantees or if they're not guarantees, and if they are or are not, go into why that is?
So it is a guarantee in a sense, in that what we're going to do in the case of a minimum is that we are going to, every time that we receive an IO, we're going to attach the deadline for when that IO needs to have been completed, processed, and response provided, for instance. And so in each one of those cases, we're going to be looking at that deadline. And as we start getting close to that deadline, we are going to start actually quick walking that particular IO through various stacks to make sure that it is acknowledged and processed within the deadline's time frame. And so effectively, it is a guarantee in that we are going to make sure that we are able to respond to the given IO within the time frame.
Okay, so QoS minimum, QoS maximum. Sounds like we are making things easier for the most part for storage administrators to control their performance and, just kind of sequester it. But in 9.3, I'm hearing that we are adding even more to simplify things for QoS. What are we adding?
Well, the biggest thing with regard to performance and QoS is that in 9.3, we predefined some service levels. We created 3 service levels, performance, value, and extreme. So the way those performance levels work is each of them are going to be representative of what a typical enterprise, the type of storage that a typical enterprise would use. So let's go ahead and start with value. Value is typically going to be something like 60 to 75% of the data under storage in a typical enterprise. Things that would fall into that bucket typically would be email, web services, file shares, group directories, backups, things of that nature. The next type of QoS is performance, and that particular one, you're looking at somewhere between 25 and say 35% of enterprises' data under storage is typically going to fall in this bucket. Most commonly, databases, virtualized applications would make up the bulk of that. And then last but not least is extreme. Extreme is the highly latency sensitive applications, typically something like 5% of less of the total data under storage in a given enterprise. And so all 3 of those buckets have predefined minimums, maximums, and an absolute minimum, which is a new term. So let's go ahead and start with, so if you look at minimum, the minimum SLA is going to respond, or it's going to look very much like a QoS min. What that's saying is and by the way, in terms of service levels, it's referred to as expected value. And so that's basically saying that this is the minimum that I'm going to guarantee for this particular workload. The peak value, which would correspond with the QoS max, is going to be the maximum or the ceiling for that particular workload. And then, as I said, there's a new term, absolute minimum. Absolute minimum is different than the other two. Both the peak and expected are both going to use Adaptive QoS, and so they are going to increase the number of IOPS available to a workload is going to increase or decrease in size based on the size of that given workload. So as the workload increases in size, the number of IOPS that are going to be available to it for both minimum and max are going to increase. Absolute min, on the other hand, is a fixed value. Absolute min is going to be set at a specific number. So for instance, with value, that number would be 75, and extreme, that number would be 1,000. What absolute min is meant to do is it's an anti-starvation tool. What it does is let's say you have a workload that you've defined, 10 IOPS per 1 terabyte of storage. And then let's say that you're applying that ratio to a workload that has 10 meg of total data under storage. You would never get an IO. In that, you would never get that ratio would never produce an IO for you. So what the absolute min does is it sets aside a certain number of IOPS that are available no matter what the size is, in order to make sure that workloads that are very small would still be able to get some number of IOPS and not just completely starve. The other thing I should note about the service levels, value, performance, and extreme, is that each of those are targeting a specific latency. So the value, you're targeting a latency of 17 milliseconds or less. Performance, you're looking at 2 milliseconds or less. And extreme, you're looking at less than 1 millisecond. Lastly, with Adaptive QoS, ONTAP is going to, every 5 minutes, take a look at the size of each of the workloads and then adjust up the number of IOPS that are available to that workload. So that will occur every 5 minutes, and that's done by default.
Okay. So pretty much just simply being able to modify your QoS policies as you increase or decrease capacity without having to deal with the extra hoop to jump through there, right?
Yeah, it basically, you don't need to do anything. If you increase in capacity, you're going to get more IOPS. And so all you would need to do is just generally keep an eye that, is this particular workload, is this service level still meeting that workload's objectives?
Okay.
So to add to this, how does one go about using these predefined service levels? The easiest way is that if you use application-aware data management, which is you go into System Manager and actually use System Manager to provision a new application. One of the things that you're going to be asked for if you do that, you're going to get 10 to 15 questions that are going to ask you things like, what kind of, what do you want to name this Oracle database, or what do you want to call this VMware application, or depending on the type of application you're actually provisioning, it will ask you things of that nature. What's the name of the database server or the VMware server, or that sort of thing. But another thing it's going to ask you for is the service level for each one of the workloads. And based on that, you are going to be assigned one of these 3 service levels.
So it kind of picks the service level for you, or you have to decide based on your application?
No, you pick the service level. So let's say you say that you want to provision a new Oracle database or a SQL database. You basically say that I want it to be 4 gig in size. And then what kind of service level should I be using for that? What sort of service level should I use for the redo logs, for instance? That sort of thing. And so that's how you have a drop-down box for the service level. So you have to pick one of these 3 if you're using application-aware provisioning.
Okay. Makes sense.
Additionally, another way that you can assign QoS is that you can absolutely assign it using the CLI. You can assign both QoS min and max using System Manager by finding the object you want to assign it to, a volume, for instance, or a LUN, and you can assign min or max to that. For adaptive, your choices are going to be either through the CLI or using application-aware. I suspect that we will probably see more in the System Manager space around that in future releases, but that's the current state of play.
Okay, so we got some stuff coming down the pipe that might make things even easier and simpler to use, right?
If someone were to guess, that's probably going to be accurate.
Yeah, I mean, I'd like to think of the ONTAP releases, and the features we add as kind of building blocks as we go, right? So you think of these features that come in, and they seem cool, but they're relatively small. For example, balance placement. I can place things based on load of my system as I create them. Okay, that's cool. What about after they're created? What do I do then? Well, we don't do that yet, but maybe in the future something might come along, and we might leverage some of the other things we've developed in ONTAP to kind of build onto that as well.
Yeah, so keep in mind, particularly with the new cadence model where you basically have an update every 6 months, the size of each of the individual payloads is likely to be somewhat smaller, and so you're going to have those modular building blocks, just as you say. And so at first, you see something that looks interesting, but you feel like maybe there's some additional use case that's missing. There's a good chance that that's going to get covered in the next 6-month drop or the one after that.
Yeah, and what's good about it is you only have to wait 6 months to a year, as opposed to the previous versions or the previous cadence, which was about 1.5 to 2 years to get new stuff, right? So things are coming out quicker. They may be a little smaller in payload, but they are overall building to better and bigger things.
And it's fairly predictable. It's very predictable when the next release of ONTAP is going to be. And so, yeah, absolutely that.
The best part about that is when we used to get asked, when's the next release coming out? And we'd always kind of just shrug like, oh. Now we can be like, yeah, it's coming out in November and it's coming out in May, June area, right? Because we know it's going to be 6 months.
Yeah, it makes it much more predictable. And this is something that our customers have, talked to us about and said that they business typically does not like uncertainty. And so the more predictable you make things, the better your customers are typically going to like it. Now, you mentioned balance placement because that's another interesting piece. It sort of ties in with the Adaptive QoS as well. Because one of the things, I'd mentioned application-aware data management. So one of the things that is used with application-aware data management is that you provision your application. You say, among other things, that I would like this service level for this particular, for the database itself, and perhaps another service level for the redo log, which could be a different service level. Well, what balance placement is going to do is it's going to look at, number one, what is the size of the workload you're provisioning? It's, a terabyte, let's say. And then what sort of service level are you looking at? And you're requesting that I want the performance service level. So now I'm going to look at my cluster and look where are the different places that I could put this workload that needs to have a terabyte of space and needs to have a performance service level. And that's what balance placement is going to do, is it's going to answer that question of where best to, how do I optimally place based on that.
I also understand that we are doing some improvements to performance overall in ONTAP 9.3. Can you go into some detail about what we're doing to make 9.3 better? The whole concept of being able to improve your performance just by upgrading software.
Yeah, so that's one of my favorite stories because it's an easy one to tell and one that people tend to appreciate. And it's just that every time you upgrade ONTAP, you will get some performance improvements. Where they are and the size of the performance improvement in a specific area will differ depending on what it is that we were focusing on with that given release. But every release, you'll typically see some benefits. The biggest one by far, and it's a blockbuster, is in the SAN space is iSCSI performance improvements. The amount that, I don't know that there's a single bellwether number that you can say that, it's 28% better or something like that. But if you look at your iSCSI performance, you're going to see, depending on, whether you're looking at 8K random reads or 4K sequential reads or, various different tests, you'll get different numbers. But we're seeing numbers in the 40% improved, the 300% improved, just all over the map. Big numbers. And the reason that we're seeing these levels of improvement is that what we did is between 9.2 and 9.3, we completely rewrote the iSCSI stack. So we have a iSCSI software target in ONTAP, and we completely rewrote that. What we did is that we looked at getting rid of context switches wherever possible, removed any locking that we could, and then tried to figure out how can we multi-thread as much of the processing as possible, doing things like moving more of the processing out of the iSCSI thread and into, say, networking threads so that we could run more of those concurrently. And where you're going to see the most improvement is where you have the controllers that have lots of cores. So things like the A700, A700S, where you've got 32 cores. When you basically multi-thread, what you're able to do is take advantage of some of those unused cores to actually go through and do some of the network processing that would be required for iSCSI, for instance. And so that's where you're going to see, fairly massive performance improvements. You'll still see performance improvements, but not nearly to the same degree on systems that have fewer cores, because that's where you're really, where it's really coming into play is being able to take advantage of large numbers of processor cores to concurrently process the iSCSI threads.
Yeah, and I mean, it wasn't just iSCSI either, right? I mean, we also made some changes to FCP performance as well as waffle performance in general by optimizing things in the back end, correct?
Oh yeah, no, absolutely. I lead with iSCSI just because the performance differences you're seeing. Some of them you're looking at these charts and going, is this possible?
Yeah, I mean, I've seen the graph.
It is such a big improvement.
Yeah.
I mean, you will see improvements in FC and frankly, any improvement in waffle is going to, it's like throwing a stone into or a pebble into a lake. You're going to have it ripple out. And that's going to ripple out across any protocol, whether it is SAN or NAS-based protocols.
Yeah, with the iSCSI improvement graph, what I saw was like 2 to 3 times more IOPS at lower latency for iSCSI alone. So I mean, that's a pretty massive jump.
Yeah, it really is just it's pretty amazing. One of the charts I was looking at was an 8K random read that was 3.6 times faster.
Yeah, it was crazy fast.
That's 360% faster.
Yep.
I mean that's the kind of number where the first thing you have to do is ask, is this believable? How is that possible?
Yeah, and in addition to the iSCSI and FCP stack, I mean, we're also doing some things with NAS performance. So 9.2 and 9.3 added some improvements for NFS 4.1. Mm-hmm. So for streaming workloads such as virtualization or databases, if you're running those sorts of things on NFS 4.1, where you have a single open and then just reads and writes to it, we're going to see a massive performance improvement for 4.1. We're trying to get to the same level as V3, and we're right at that level as V3. So you get all the benefits of 4.1, with the locking mechanisms and the security, but you also get the performance that we weren't seeing before with 4.1. And then future releases will improve performance for 4.1 on metadata operations. So I would look for that in the next 6 months to a year as well. In addition to that, we added offloading for Kerberos 5P, so the encryption piece of NFS, being able to offload that to the AES-NI processing module on the processors to give you performance that's equal to just regular Kerberos. So you can not only encrypt your authentication, but you can also encrypt your entire NFS packet stack there.
We have absolutely doubled down on performance. Clearly areas that we're just looking at results that you can see a lot of focus. This is going to be performance and simplicity and just general hardening. This is looking at how to be more secure in a world that clearly, with things like the WannaCry and so on, you're seeing more and more requirement for that, or you're seeing more requirements and RFPs for that you have on disk, encryption, for instance.
Yeah, absolutely. I mean, we've really taken performance seriously, and part of that is because we're adding new features that require the need for more performance. And then when you look at things like NetApp FlexGroup volumes, which allow you even more performance out of multi-threading, we're trying to basically use the building block methodology with the NAS stack to improve the performance on that end, so that when it gets to flex groups, we're not suffering any sort of hits because we're using NFS 4.1 in those cases. So anything else in 9.3 performance related or SAN related that you wanted to add?
Those are pretty much the big ones right now. That has been our focus. The one other thing that it's coming down the pike, we have done some previewing of it and are very active in the space, is around NVMe OF. So NVMe is non-volatile express or non-volatile memory express. OF is over fabric. And underneath that, you have a number of different choices, one of which, and the one that we've picked to pursue first, is FC NVMe, which is the idea of using NVMe over fiber channel. So what you're doing is encapsulating an NVMe command descriptor instead of a SCSI-3 command descriptor. And because of improvements in the streamlining and efficiency of NVMe, which is a protocol that was written in the last couple of years instead of being backward compatible to the mid-'80s, as well as improving by removing things like context switches and locks, we're seeing fairly significant improvements in latency when all other things are exactly equal. So you're going to the same workload on the same controller, same type of disks, same servers over the same fabric, et cetera, and yet we are seeing fairly substantial latency reductions and performance improvements simply by switching out the protocol. Basically how it is that you issue the commands and how much you're able to multi-thread that. And so you should stay tuned. You'll see a lot more of that. We're absolutely leading in that space right now. And you should be seeing an offering in the not distant future. It'll be a whole new protocol for NetApp.
Yeah, I mean, we announced some things at Insight, if you were there, at the general session. They actually did a demo. We also covered NVMe on the podcast in episode 72, just to kind of give you an idea what it was and demystify it. Really, the overarching theme there was that it's cool, but it's not like a game changer necessarily, the NVMe protocol. It's what you do with it that's going to be the game changer. So some of the things we're doing on the creative side of that in future releases is going to be very, very interesting for ONTAP. We already ship NVMe attached storage within some of the platforms on board, so we use that as like a flash mechanism. So we already have NVMe being added to ONTAP as we speak, but we'll be doing more with that in coming releases.
So actually, not only do we already ship, but interestingly enough, we have shipped more NVMe media than anybody else, including vendors who maybe have made a little bit more noise about NVMe. We're at 10 petabytes shipped so far, and right now that is basically just caching mechanisms in front of the FAS 8200, 9000, so on.
Yeah, it's interesting because caching mechanisms are kind of funny because competitors or people that kind of are naysayers will point to the caching mechanism to say, well, you're just caching. That's why you're so fast. And really the end result is that it's faster. And that's all that matters, right? And the customers don't care whether it's cache or not.
Assuming that you're fast, reliable, and economic, okay, sounds good. I'll take that.
Yeah, I know. Like nobody points to the race car that has the nitrous booster and say, "Well, you're just using nitrous. That's why you're faster." Well, okay, cool. Yes. That's right.
One of my very favorite, I'm going to rat hole for just a second here, but one of my very favorite pieces of FUD that I love hearing about is this is how we're emulated SAN because we're SAN built on a file system, so not from the ground up. So, yet another iteration of that whole thing. Well, so we're emulated SAN that is more performant, more reliable, more flexible, plus we have NAS. And so exactly what's the downside here? Sounds to me like we built a better mousetrap.
Well, what's hilarious about the from the ground up FUD is that the same people that were touting that FUD for a while are now starting to see that it's backfiring because the built from the ground up methodology was great for what they were building, but now that things are changing and media is changing and the protocols we deliver them are changing, they are now no longer built from the ground up for the new stuff.
Yeah, it becomes a very inconvenient data point. Interestingly enough, and we I can't claim on Dave Hitz and James Lau's forward thinking, but when they created Waffle, they created a file system that really was beautifully designed for Flash 25 years before anyone had even considered, even science fiction writers were not talking about Flash at the time.
Well, I mean, it's funny because Dave Hitz has gone on record as saying, yeah, cool. We it's a happy mistake, right? I mean, it was lucky. I mean, they didn't think about it being this good for what it's used for, but once they started retrofitting it and optimizing it, they started noticing the benefits right away.
Yeah, and I'll take luck when it happens.
It's better to be lucky than good sometimes, right?
Yeah, well, I think that's what Napoleon used to say when picking generals.
That's a terrible. Yeah, let's not use Napoleon because he didn't last very long. Got so close though. We're aiming for world domination, and Napoleon never got there.
There you go.
All right, Mike. A lot of good stuff added in ONTAP 9.3, and in reality, over the last few ONTAP releases, in terms of performance and managing our performance, simply, making sure that we're adding that simplicity story into the whole stack as well. So, Mike, if anyone wanted to get in touch with you to talk about performance or foreign line import or NVMe over Fabric or whatever, because you seem to cover everything, how would they reach you?
Well, you can reach me via social media at NTAPFLIGuy, or alternatively, my email is mpeppers@netapp.
All right. Thanks a lot, Mike. All right, that music tells me it's time to go. If you'd like to get in touch with us, send us an email to podcast@netapp.com or send us a tweet @netapp. As always, if you'd like to subscribe, find us on iTunes, SoundCloud, and Stitcher, or via TechOnTapPodcast.com. If you like the show today, leave us a review on behalf of the entire Tech on Tap podcast team, which today is me. I'd like to thank Mike Peppers for joining us today. As always, thanks for listening. So, Mike, did you have a high-performing Thanksgiving meal?
Yeah.
It was, I don't know about high-performing. There was a whole lot of it, and there was not much performance afterwards unless you count napping in the lazy boy, in which case I was aces.
Oh, yeah. I had...
And it does the trick every time, especially, 3 or 4 pounds of it.
So, NetApp may have Adaptive QoS, but I have an adaptive waistline. Yeah. So you just unbuckle the pants and you're good, right? You just spread it out. IOPS per terabyte.
I have but one word: elastic.